Good afternoon. Thank you very much for this opportunity. And I would like to talk about a program. We actually have a joint program between several organizations in India and in Netherlands. And if you look at the list of authors, many of us are from Dutch universities or Indian organizations. And what we are actually looking at is an opportunity for achieving negative emissions at negative cost or income generating negative emission options. Well, to start with, we actually look at coffee-based interventions and especially converting coffee plantations to shade coffee plantations. And why? Well, with climate change, global warming, coffee plantations are under threat. And shade coffee conversion might help with managing local temperatures and helping the farmers to continue with coffee production. So this is probably something which might anyway help coffee farmers. And why negative emissions? This is Nature editorial in 2018. 2015 Paris Agreement gave politicians an answer: negative emissions. The technology to reduce the amount of carbon already in the atmosphere will buy society valuable time. The next paragraph is also from 2018. The IPCC is now working on a report on strategies to keep warming to under 1.5 degrees Celsius, which is due to be published later this year. By necessity, those strategies will lean heavily on negative emissions. Scientists must continue to spell out to policymakers the harsh reality of what this will involve, and in strongest possible terms. Well, it's important to talk to policymakers, but it's also important to come up with say solutions. Engineering the solutions is also important. So that's something which we would like to work with. And then in 2018 itself came this MIT and Stanford joint paper. Professor Arun Majumdar from Stanford and Professor John Deutsch from MIT published in Joule, and they suggested also looking at combining biological sciences and engineering sciences to come up with negative emission technologies for gigaton scale carbon sequestration. So, well, there are not many practical examples for such approaches. So we thought of well, working with a village carbon neutrality program in India to come up with, hopefully, to come up with such a solution. Well, we actually have a paper on this negative emissions at negative cost, an opportunity for a scalable niche. This is accepted, and the abstract is already available with Frontiers, a special issue on negative emission technologies of Frontiers, and I think it should be fully online soon in the coming days. But also a preprint is available, and the link is also given here. So whatever I present today, you might also well go through the preprint or the paper when it is fully available in the coming days. But it's one of the papers from our team. And what we suggest, coffee farm. So what you see on the left side is a coffee farm. And the next, you have a shade coffee farm where actually shade trees are there in the coffee plantation. And we actually suggest, for example, trees such as jack trees to be used as shade trees in coffee farms. And jack trees produce food, a lot of food, like from 1 hectare, 30-40 ton food production is also probably possible. And the timber is good for construction. And 20 to 30% shade might not significantly affect coffee production. And so temperature management in the coffee plantations now a bit easier. Additional income generation from food production and also from timber from jack trees. And we actually would like to bring in bioenergy and biochar, because if you have such plantations, farm forestry or shade coffee plantations, it might be possible to get around, say, 10 tons of biomass from agro waste from these plantations. And it's possible to use this for producing biochar. We heard about biochar also in the last presentation, but also biofuel, maybe for cooking, maybe for small scale applications, etc., etc. And the biochar is possible to use for soil amendment. And we have seen that with large scale field trials across the globe, in general, we have seen positive influence on crop yield. So it's also something helpful for farmers. So if you do this, what we can actually do per hectare, imagine that we have a jack tree and bringing additional income of the order of, say, €1,000 from 10-ton jackfruit. And jackfruit is very rapidly emerging as a meat replacement. It's a staple food. It can be used as a fruit. It's also staple food. So to replace rice or wheat, it's possible to consider jackfruit as an option. And if you have 30-40 ton jackfruit production per hectare, so compare it with rice or wheat, maybe 2, 3, 4 tons, or 5 potato, 20 tons, etc., etc. So we might also be able to have trees, farm forestry with food production. And one of the easy first step is actually shade coffee conversion, and income from jackfruit, then income from timber. So on an average, say €500-600 per year. These are all conservative estimates. And then if you have 10-ton biomass waste, you get pyrolysis fuels, 5-ton, whatever. And this is probably enough to replace around €1,000 plus fossil fuels. And biochar, we could actually use it for soil amendment. And then from per hectare, might be possible to sequester around 10-ton CO2, 10-ton plus CO2, while creating an additional income of, €2,000 to €3,000. So it might be possible to double the farmer's income while achieving carbon neutrality and achieving negative emissions from the farm. So farm forestry and coffee plantations, forestation is a non-negative emission approach, soil amendment with biochar. And if you have trees, so coffee farming is normally in hilly areas, and slope stabilization is becoming important to prevent landslides, etc. Carbon sequestration, soil carbon in many tropical regions close to 1%. So 1 to 2%, normally far better probably for farming. It also helps to retain water. So water shortage problems, a potential solution. Doubling the income for farmers, climate change, resilience and the ability to adapt with the slope stabilization and water retention, etc., etc. Well, farmers need to accept this. Many are already commit, and especially there is a village carbon neutrality program in India. And we actually have, so they have planted hundreds of thousands of trees in the village. They have around 3,000 hectares of coffee farms, normally small homestead farms, 1 hectare per family. And of course, there are concerns, competition for sunlight, nutrients, etc. So you cannot actually go for more than 20-30% shade. Species selection is important. Invasive species should be avoided. And biodiversity management is important. But if you do this, soil and water management might become easier. And with new farm management practices are to be introduced, and probably marketing carbon neutral coffee might also give an opportunity for the farmers to increase the income. So this is all the carbon neutrality program in Minangadi, we're actually looking at all these options. But when you combine all this, we actually have carried out a survey in the village, and we have seen acceptance rate for a negative emission technology above 90%. This is probably the highest acceptance rate for a negative emission technology reported anywhere in the world. We need to double check it, but it seems in Austria, 70–80% probably is a highest acceptance rate reported till now. And we have actually seen that it's about 90%. This is also published in a paper, Agroforestry in Shade Coffee Plantations as Emission Reduction Strategy for Tropical Regions, Public Acceptance and the Role of Tree Banking. Well, then what is tree banking? So if farmers plant trees in the coffee plantations, and it's possible for them to get lots. So for that, tree growth is to be monitored, and trees should become sort of bankable assets. We are also developing tools for this, for example, with remote sensing, etc., etc. And this is already introduced by the government of Kerala. So it's not it's an initiative from the government to introduce this tree banking scheme in a limited manner, and large-scale implementation is yet to start. So for the details, please have a look at this paper. This is also connected. It's again the special issue for on negative emissions, published in Frontiers 2 weeks ago. Now, energy systems. Well, efficiency increase is important. So high efficiency systems we should look at. Renewable energy and fossil fuel replacement whenever possible. Affordable solutions are needed. Maybe microgrids, etc., to reduce the dependence on grid electricity, because very often grid electricity is coming from fossil fuel-based power plants. Waste to energy, biogas plus slurry production, or pyrolysis plus biochar production. So bioenergy and biochar production is actually becoming an interesting option. There are very simple options like go for pyrolysis stoves and then biochar production, but also it's possible to think of high-end technologies. For example, in the previous presentation, we have heard about solid oxide cells. So we actually, well, we have started looking at also the simpler technologies, but also bit advanced technologies with very detailed modeling. So this is actually again first in a two-part series on negative emission power plants, thermodynamic modeling and evaluation of a biomass-based integrated gasification solid oxide fuel cell gas turbine system for power, heat, and biochar production. So thermodynamically, we have shown that high efficiency power production is possible with air gasification or steam oxygen gasification, with steam oxygen gasification performing a bit better. And in the second part, so if you have detailed thermodynamic models, you have mass and energy balances, and you actually get indicative component sizes. And following closely what NREL has done, National Renewable Energy Laboratory has done, we actually looked at the costs for such a system in the future. And what we actually have, so the second part of the series is also right now accepted. It's also available again, Frontiers special issue on negative emission technologies. And it shows that such power plants, probably it's possible to have a payback period between 3 to 5 years or more, especially if and when the solid oxide fuel cells become are mass produced at say probably $1,000 per kilowatt or around in that order. So these technologies are becoming interesting, but this is, of course, if you have a very large power plant for several thousand hectares of coffee plantations, you might also think of other small scale options. And the solid oxide fuel cell, again, the advantage is that oxygen is automatically separated from nitrogen, and the anode chamber fuel is oxidized, resulting in the production of CO2 and steam. And because the fuel is not completely electrochemically oxidized, whatever remaining fuel is, if it is oxidized in an oxy-fuel combustion chamber, you get steam and CO2. Cool it down, you have a pure CO2 stream, which makes CO2 sequestration far easier with solid oxide fuel cells. And from the gasifier, you can also remove biochar, and this biochar could be used for soil amendment. So it's possible. Well, this is for the future, but it's possible to think of biochar production and bioenergy with coffee plantations with far simpler technologies such as pyrolysis stoves and gasifier stoves, etc. But eventually, people might actually start looking at, well, stoves are not easy to handle. They might look at other options, etc. Then you need such advanced technology-based power plants. So we are actually looking at also a series of options for now, but also for the future. Now, summing up, agroforestry with shade coffee, and especially bringing in food and timber producing trees, bioenergy systems with biochar production. Well, what we see here is climate, energy, and water nexus, hopefully negative emissions at negative cost. So that's all from my side. And we have a series of papers already published about it or accepted. And you are most welcome to go through these papers. And if you have questions, please feel free. Thank you. Thank you very much.
Thank you. Thanks for the presentation.